There's a problem with negative orders of motion. Well, how they're named. In order to understand, let's imagine you're a particle with coordinates 0. That's it. I should say we'll only be traveling in the first dimension, sort of a number line. To where exactly? Well, only 10 meters away in the positive direction. So how do we change our position? How do we displace ourselves exactly 10 meters away? A form of wormhole teleportation? What about an easier way? Like, what if we started you with a positive velocity? Let's say 1 meter per second. Now, in 10 seconds, it'll take a while, you'd be 10 meters away. Don't worry about the other seconds. Okay, what if your position was 0 and your velocity was 0? Well, you do the same thing, kind of. We'd give you a positive acceleration that changes your velocity the way that a positive velocity changes your displacement. Let's say 1 meter per second. And although your velocity starts out slow, it will reach the speed of light in about 9.5 years. Maybe Silk Song will be out by then. Okay, wise guy. Now everything's 0. Your position, your velocity, acceleration, your bands, you have no bands. What about now? Well, if you study physics, you probably know this. Jerk. Jerk is the measure of the rate of change of acceleration over time. It's important to know jerk because you want things to accelerate smoothly in mechanical engineering and whatnot. But I bet you didn't know this, or maybe you do. It's a quick Google. The higher derivatives are snapped and crackle and finally pop. It's the name of the cereal. So rest assured, if your crackle is 0, then what was the point of this video? Okay, cool. We can go up the ladder of derivation, but can we also go down the damp, dingy basement, creaking, right past displacement? Well, the same way we can integrate pop to get crackle and crackle to get snap, we can integrate displacement and we get absement. Okay, sure, anyone could put a name to anything, but what does it mean? And more importantly, what is this unit? What's up with this unit? Well, it's not a millisecond, it's actually a meter second. Okay, let's say you're 4 meters away from the origin, and your particle friend, let's make them yellow, is at the origin, but slowly coming to you. In about 2.5 seconds, they'll meet you, and then slowly pass you, traveling the same speed for another 2.5 seconds. At the end of the 5 seconds, they're 8 meters away from the origin, but you're 4 meters away. Still, both of you have the same absement. Although your friend ended up more displaced than you, they were less displaced for half the time, and only became more displaced the other half. Absement is not only the measure of displacement, it's how displaced something is, and for how long. That's what the multiplication is. Comparing the absement of a moving particle and a non-moving particle is like comparing the position of an accelerating particle and a non-accelerating particle, which is what we did in the beginning of the video. Integrating further, we get absity, or how far your absment has accumulated. Then we get acceleration, or how far your absity has accumulated, and so on. The units are meter second squared and meter second cubed, respectively. What? This should come as a shock, a fright, and a real velocity is measured in meters per second, but absity is meter second squared. Same with acceleration. Why are the times exponents not inverses? Well, you see that all the negative orders of motion are named to be in parallel with the positive ones, with your silly names like absurd, absnap, absackle, absop. So, why does it seem like they're all offset by 1? The culprit is this guy. This guy shouldn't exist. Okay, imagine if you're counting up and you get to 9 in a base 10 system. You ran out of all the numbers. You recruit the help of the tens place to restart the count, and then continue the count, so on, so on. There's a tens place and a hundreds place, thousandths. Okay, what about decimals? Well, we also decided to name them parallel to the integer side. We have a tenths place, hundredths place, thousandths, and so on. So imagine if, for some reason, we decided to stick a oneths place in there right in front of the tenths place, so that the 10 to the power of 1 area was called the tens place. So far, so good. 10 to the 0 was called the ones place. 10 to the negative 1 was called the oneths place, instead of the tenths place. Displacement has nothing to do with time. It's only when we derive and antiderive with respect to time that we get these terms. So why is displacement's integral called absment instead of absity? Oh shoot. Guess I have to beat Hollow Knight now.